Hello, in this video I'm going to solve the following gold level problem on the topic of limit of a sequence, one variable calculus. This is a problem from India. The following limit as n approaches infinity, sigma k goes from 1 to n, sigma r goes from 2 to 11, of the nth root of r to power 2k divided by n times the nth root of r to the power of 2k plus r is equal to. Pause the video at this point and give it a try to see which one of the given following options is the correct solution to the problem. Okay, to solve this problem, I'm going to use this famous theorem from one variable calculus in the topic of integration, the relation between integration and calculating limits of sequences. That theorem tells you that if you have a function f which is integrable on the closed interval from 0 to 1, for example, let us say f is continuous on the closed interval from 0 to 1, then the limit of 1 over n sigma k goes from 1 to n f of k over n as n approaches infinity is equal to the integral from 0 to 1 f of x dx. So in other words, instead of calculating a limit, if the limit has this particular form, I can calculate the integral of that function corresponding to this limit on the interval from 0 to 1. This is a famous theorem that guarantees that these two values will be the same. What motivates me to actually think about this theorem in the first place? Okay, first of all, you see the commonalities. Here I have the limit n goes to infinity. Here I have the same. Here I have a sigma k goes from 1 to n. Here I also have a sigma k goes 1 to n. And one thing that is very important in these kinds of limits is this factor of 1 over n, which is also present here because this is just 1 over n, which can be pulled from sigma. So I don't have any problems with that. Then I need a function which is a function of k over n, and a closer look to this expression will immediately reveal that that's also the case, because the nth root of r to the power of 2k in principle can be written as r to power 1 over n to power 2k, and then it becomes r to the power of 2k over n. So that is exactly the function of k over n, which appears both in the numerator and in the denominator. Okay? The only apparent obstacle in front of me is this second sigma, which is a little bit of deviation from this main theorem. But that's also not a big problem because both of these limits are finite sums, so I can simply replace them. And this sigma will go inside, and this 1 over n can be pulled out from the first sigma. And then I calculate these limits of these functions, okay? So if I want to think it in this way, I would think it in this way. I would say that this becomes the limit n goes to infinity. I replace the location of these sums. R goes from 2 to 11, and then I have a second sigma. K goes from k goes from 1 to n. That's correct. And then I have r to the power of 2k over n, and then in the denominator I also have r to the power of 2k over n plus r, but that 1 over n can be pulled out from the first sigma now. Yes? But now look, if I can calculate this limit of this sequence as n approaches infinity, and I'm lucky and this limit exists for any choice of r between 2 and 11, then this sum doesn't impose any problems, yes, because I can just add up the limits. So this is why I would say that with the hope that all these limits exist, I am allowed to replace the summation and limit operations. So I'd write sigma first, then I would write the limit of 1 over n, sigma, k goes from 1 to n, r to the power of 2k over n, divided by r to the power of 2k over n plus r, n goes to infinity. If you want to, I can put it and a little bit big pair brackets so we know what we are doing. So now I will concentrate and calculate this limit. Of course, in order to justify the interchange of sigma and limit, first I have to convince myself these limits exist in the first place, and then I am allowed to do that. Okay, but we know that this was going to work, so this will, if I calculate this limit and this limit becomes a number, it automatically justifies this interchange of operations here as well. Okay, but now compare this one with this formula. Okay, so this is going to play the role of f of k over n if it is possible to use this formula to solve the problem. A little bit of comparison, a very simple comparison, shows that what is f of x? F of x is r to the power of 2x divided by r to the power of 2x plus r. Why is that? Because if I choose f of x in this form, then what will be f of k over n? I have to replace every x with k over n, and I get this exactly. Okay, so that is correct. So this means that this limit, let me call it L, this limit L becomes integral from 0 to 1 f of x dx. Why is that, by the way? Because this function is continuous on this interval between 0 and 1. Because r starts from 2, it's an integer, goes up to 11, so the denominator will never vanish, so this function is a continuous function, so and it is integrable then. Okay, so I need to calculate this integral, and this integral is simple, so I have to calculate the integral from 0 to 1, r to the power of 2x divided by r to the power of 2x plus r. Note that this r is any integer between 2 and 11. It's a fixed one, okay? I fixed r. So, and this is also very simple. So if I want to use the method of substitution, for example, I can take r to the power of 2x plus r, my new variable. Then I integrate both sides. I differentiate both sides. So I want to use this formula. If you have a fixed number, to power u, a function of x, and if you want to differentiate it, hopefully you know that this becomes the same function multiplied by ln of a, and then multiplied by u prime. Okay, so I will use this formula on the left-hand side by giving the role of r to a and giving the role of 2x to u. Okay, and then of course I can calculate the derivative. It becomes r to the power of 2x ln of r multiplied by the derivative of 2x, which is 2, and then plus the derivative of r, but r is a constant, so its derivative is 0, and everything multiplied by dx, and on the right hand side I will have du. Okay, now look here, this expression is exactly this one multiplied by that one, so this means that r to the 2x dx is equal to 1 over 2 ln of r du. Okay, and the second thing that I have to take care is the new limits. Yes, let us calculate that one as well. So if x goes from 0 to 1, which of course it does in this case, so what are the limits for u in my new variable? If r is 0, then u becomes 0. Okay, so this will be 0. But what about x equals to 1? If x is equal to 1, then u becomes r to the power of 2 plus r. And I factor an r out, so it becomes r times r plus 1. Okay, so this means that the limit L, which is equal to this integral, now can be written in terms of the new variable u as it goes from, I made a mistake here. I accidentally, so that is correct, but this one is not correct. You see, I have to replace x with 0. I replaced r with 0. If I replace x with 0 here, this becomes 1 plus r. So it becomes r plus 1. Okay, so this becomes r plus 1. up to r times r plus 1, and then I have 1 over 2 ln of r du, and then I have u. But that one is a constant. 1 over 2 ln of r is a constant. I pull it out. And then what is left here is a famous integral, so it becomes ln of absolute value of u, which I have to run it from r plus 1 up to r times r plus 1. Okay, so this becomes 1 over 2 ln of r, and then you have ln of absolute value of r plus 1 minus ln of absolute value of r plus 1, but of course here we don't need absolute value because r is a positive integer here, but I can use the property of ln and write this as ln of r times r plus 1 divided by r plus 1. Oh, I have forgotten to write r here. And now look what happens. This r plus 1 and that r plus 1 are gone, and what is left for me is just 1 over 2 ln of r multiplied by ln of r, simply 1/2. That's a very interesting result. So this means this limit, whatever r is, it becomes 1/2. Okay, so the question mark that I was looking for is now easily found. The question mark, do you remember? The question mark is the sigma of this limit. Okay, but this limit is always 1/2, so this becomes sigma of 1/2. R goes from 2 to 11. So sigma of a constant means that how many times this constant is being repeated. R starts from 2 up to 11, so there are 10 of them. So I have to multiply 10 by 1/2, and the answer becomes 5. So the answer to this problem is 5. And then of course option B is the correct answer to this problem. I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.